Hey folks. If someone can let me know if the music is like overpowering my mic or whatever, just let me know. Cool. Thanks so much, guys. I can tune it down just a bit. Yep, I just started. Just give me like 1 or 2 minutes to figure everything out, and we'll get going after that. I'm going to spam you guys with Scott today, I think. No, well, I do have Flare VM, but I'm not currently running anything in Flare VM. Alright, so I think we are going to get going. Hey everyone, how's everyone doing? We are going to be looking at what is dubbed the DEVMAN ransomware. I'll start by maybe just running you guys through how I kind of initially found this, and then we can look at it together. So let me just go back to the main page of Malpedia. Just take this down a bit, increase that just a bit. Alright, so to give you guys a bit of context, I am, not someone who does this for a living. I reverse engineer malware kind of for fun. And the way I try to stay like up to date with new variants and new samples that get submitted online is typically through Malpedia. You guys can let me know if I need to like increase my font a bit or whatever, so you guys can kind of see what's going on. So typically what I will try to do is just kind of look at the inventory updates on Malpedia. So to give you guys more context, Malpedia is essentially a kind of malware encyclopedia, I guess. They try to index threat actors, new malware samples, and they kind of filter on them based on the OS. Ari's asking, preparing for a gram, should I go with you analyzing it? Honestly, I don't recommend doing it at the same time as me for today, just because there's like quite a bit of work that I've already put in so that the stream wouldn't be too boring. There's like quite a bit of string obfuscation going on. Yeah, I don't recommend following along for this one, especially since it's a bit of a weird one. Yeah, so I typically just like try to look at kind of the inventory updates. By default, it's only going to show us like the kind of last 3 days. But if we go into the complete changelog, and I can paste this in the chat for you guys, we see that we have like all of the changelogs throughout the year essentially. And what I typically do is I just like open a bunch of them. Let's do that right here. And I try to just like look for new families. I think, how did he call it? This family was added, so we can do like this family. And then I kind of can quickly jump to like the latest new families. So these are families that weren't present before and have just recently been added. So typically this kind of gives us a hint that it's at least somewhat recent. I think there's still value in like reviewing older malware, but in my case I'm just like kind of looking for newer stuff because I'm like that, I guess. And I like making things more complicated than they need to be. So this is kind of how I like started looking at this. And at some point I ended up, I think it was on the second page, finding out about a new ransomware sample, well, quote unquote new. There's some analysis that was done in September 2024, but it's still like fairly recent, all things considered. I just opened that, and if I search for DEVMAN, there we go. So after like reviewing quite a few samples, I ended up settling on this one. So if we look at it from the Malpedia perspective, all we're seeing is like DEVMAN is a ransomware, which is fine, which a large part of its code base coincides with the Dragon Force ransomware. It's highly probable that a group used a Dragon Force ransomware build and simply changed the extension, blah blah blah. So this is, you know, it's interesting. It gives us like a bit of information. It also supports multiple encryption modes, so full encryption, header-only encryption, and custom encryption. And finally, typically we'll see like a few more details about the given sample, such as the one here where we see that it's creating a temporary session under the following registry key session quado. So I found this interesting, and if we look at the two articles that are linked, one of them is from AnyRun, where they kind of, and I can share this in the chat too. One of them is from AnyRun, where they kind of just like briefly go over the sample and kind of what it tries to do and things like that. It touches on like the ransom node that it's dropping, the files that are created, its offline behavior, the encryption mode, file targeting. So like there's a bit of information there, but it wasn't like quite what I was looking for. I typically like getting the kind of more technical details about samples, because that's kind of how I learn. And then if we look at the search report, it's a bit better, where we see like a bit more information. But what I did find interesting is that the actual hash that's provided there doesn't actually match the reports that we're seeing there. So it's similar, but it's not the same. Like if we open it in Detect It Easy, we see it's the hash that we saw in Malpedia. And if we look at the sections, interestingly enough, we don't see like any .config sections mentioned. We do see that like there's an overlay, but I kind of tried to dig through it and I couldn't find anything similar to that. And we do have like a bit more information about the supported arguments. Once again, this isn't exactly the same. It's similar, but it's not exactly the same, and we'll see that a bit further. What else did we have? We had a few more hashes. So this does kind of highlight like one thing with Malpedia is that it's an open source community, and one can like propose changes and things like that. So sometimes you have to take the references and the descriptions with a slight like grain of salt, because it's not necessarily always accurate. But all in all, yeah, like the information tends to be very good. So if we look at just another random sample to show you guys, like Luma is super well documented. There's some good information about, you know, how it works. There's like a ton of references for it, so that's always great. Do you also use samples from VX Underground? So VX Underground is like a bit less structured than Malpedia, so I tend to rely on Malpedia a bit more, just because I guess, you know, it's like ClickOps. You see all the fancy stuff, and it like feels more intuitive to use, I guess. But at some point I do intend on making something to kind of make it easier to see what's been uploaded and things like that to VX Underground. So that kind of sums it up. And on a more like general note about Malpedia, it is like quote unquote open source, but you do need to like reach out to them to get an account. Sadly, not anyone can just like create an account. Please note that Malpedia does not feature open registration. It's operated as an invite-only trust group. You know, I out of respect for them, I won't disclose how to join that, but it's really not too complicated. Just, you know, go a bit on the website and see if there's anything that stands out to you to register. And it's not like a CTF or whatever. You just gotta try reaching out to people. So this being said, another also like nice thing about it is that you can like track your own submissions. So I've got a few of them as of now, but it's something that I like try to put a bit of time into, just because I feel like the website is super nice, and you even get some nice like achievements, and they do polls about renaming samples and things like that. So that's pretty cool. So this being said, if we dive back into DEVMAN itself, we see that there's like the 2 reports and that were a bit and one nice feature about Malpedia is that you can actually download the samples directly from their website. So for cheap folks like me who don't have a VirusTotal license, oftentimes you can get access to the sample directly on the website, which is super nice. And on other samples, you can even get some Yara rules and things like that that you can access. So that's super helpful if you want to, you know, try to identifying things left and right. So that kind of sums it up for Malpedia. It's not cheap, folks. VT is just too expensive. Yeah, I do tend to agree with that. I even like tried looking at it recently to just like buy a kind of like researcher license or something like that, and I couldn't find it anymore. So I feel like they've completely pivoted to like enterprise only license model essentially. Because I do remember that like we could have like smaller licenses and things like that, but that doesn't seem to be there anymore. Okay, yeah, they're enterprise focused now. Yeah, which is, you know, it's a shame, because I felt like it was a super good source. But one trick that I can drop for those who don't know, so for a lot of samples you'll see like a bunch of community notes. And let me just like sign in real quick so that we can see the whole thing. And in the community notes, oftentimes you'll see people posting URLs of like where it was analyzed. And no, I'm not the Hercora, I'm just bald like him. So we see like some AnyRun submissions, we see some file scan submissions, you know, we see like a bunch of stuff. And oftentimes when you go on like these URLs, then you can download them from there. So for example, like file scan, triage and stuff like that, these are all websites that you can at most just need like a kind of a free account to download them from. I know, I don't know if it's like Nike or Nike.dev, they have closed registrations as of right now, so I wasn't able to download it from there. But yeah, so oftentimes, you know, if you look in VT and you don't have the license, you can just kind of rummage through the comments to see what's going on there, and sometimes you can download it from those links. So if we look at the sample at hand, just from the VT analysis, we see it's like not a small file, but it's not that big either. We're not in like megabyte territory. We see it's a P32, just like a generic executable, most likely compiled with Microsoft Visual C or C++. And we got some linker information. We see that we have 1, 2, 3, 4, 5 sections, which don't look too unusual. We have like a few imports. And if you are trying to like not use VT because of reasons, Detected Disease is a super good local alternative. I typically try to use it as much as I can, just because all of the info is there, is super easy to navigate and everything. So there's that. So if we load this into Binja, and let me just get like a clean untouched sample. Let's do that. It should be this one. Let's not open the existing database. So I'm just gonna let it do its thing. And Binja not too long ago added warp support. So warp is, if I understand it correctly, it's similar to what IDA has with the what is it? It's flare signatures, I think. So it's going to find functions that it kind of knows what it looks like based on a fingerprint, and it's going to apply the right types to it, which is pretty nifty. So in this case, we see there's like a few functions that have been tagged by warp. So if we delve into the start function, we can skip directly to what we should be considering our kind of main function. Or I think, isn't that like some CRT stuff? Let's try to find our main. I have it highlighted here, so let's just look at our main. And main gets called by 435255, which is our function there. So main is right here. So we should have it right there. Okay, so that's going to be our main function, and I'm going to switch back right after this to the like marked up version, but I just wanted to show you guys what it looks like out of the box. So we already have like a few types that have been applied on some structures. We do see like a few interesting APIs being called, like get command line W. We see create file W. What else? We see some basic like logging information. We see process elevated, which is always nice when like malware authors leave these in. It's always like a kind of good pointer as to exactly what's going on. We see, obviously what looks like some obfuscated strings. What else? I'd go over this like a bit later, but Binja was having trouble kind of reconstructing the I guess we can call it like a byte array, the kind of strings. For some reason, this isn't the first time I see this with Binja, so I feel like it's just a kind of small bug on their end. But it's fairly easy to kind of reconstruct what's going on there when you're looking at the assembly. What else? We have more strings here. We see like a few functions being executed with what looks like potentially a hash, or at least like an init value. Not undefined if we look at display as. Okay, so it's just values. We have more strings there. We have some interesting operations there. We have is64 process being called on the current process, which is interesting. And it's saving that to this. We have more memcopies with the same function here. We see that it does create a mutex, which is interesting. It's looking potentially at number of processors. It's probably going to create some threads where we see like kind of thread-like structure being created there, and we have create thread right under. What else? Initialize critical check section, which is interesting. More thread creation. So it's making a snapshot of the process. It's cycling through processes. More thread creation, and that sums it up like at a kind of cursory glance. Hey folks who are just joining, how's everyone doing? So just to kind of go over this a bit more quickly, so this like section right here is essentially the string deobfuscation. So it's not too complicated, but as you see, it's kind of annoying because this value and these value change on every string deobfuscation call. So we're kind of gonna have to adapt to this. I ended up not having the time to like create a Binja script to decode all of these, but I did end up with like not too complicated Python to deobfuscate these. So if we go back into our annotated main, just because it's going to be a bit cleaner. Let's go right here. All right, so what I initially started doing is just trying to give like some, like, how can I put it? I kind of like estimated, you know, function names just to give me like a pointer as to exactly what's going on. So in this case, we're seeing like more string deobfuscation. We see our string deobfuscation routine. So right here we see it. So we have like, this time it's like times 0xf minus 0xf. And then we have a load library call, which is interesting, on the string that we like just decrypted. So in this case, it's kernel32.dll. So we know that this is going to be an H module to our kernel32.dll. Just a bit lower, we have another string that is going to be decoded, which resolved to, I did a small typo there, but ADV API 32.dll. I never know how to pronounce this one. We have this, we have NTDLL, that's gonna get resolved right there. We have OD32.dll. So all of these are interesting because when we look at the actual imports of our file, they kind of just match with it. I think on most APIs, if I'm not mistaken. So we have like kernel32, we have adv API 32.dll, OD32, which is a bit lower. We have this one I haven't looked at yet because I was curious to dig into it with you guys. Net API WS32, most likely for network connectivity purposes. So we have like a bunch of stuff there. So we're seeing like a bunch of libraries being loaded left and right, which is interesting. And this one, which I hadn't identified yet either, which, you know, at this point I feel like it's going to be some function loading, because we check if we manage to get a handle on our module, and then we run this function with our module as an argument. We have more string deobfuscation, and so this was kind of weird, where we're passing it like an H module to kernel32 in this one, but then we directly proceed at decrypting and reloading kernel32.dll. So I wasn't like too sure what was going on there. And then we get, oh, is it going to compare it? So we get the module file name of our module that was passed as an argument. We save it into var214. Okay, so yeah, so we're just like reopening it, which is like a bit odd, I guess. Because we have our handle, we get its file name, and then we create file with open existing. Okay, so it's just going to like open kernel32.dll as a file, which is interesting, I guess. What other parameters are passed? Yeah, not too much. So we have our file handle, we get our file size, so it's mapping it in memory. If the number of bytes mapped are equals to 0, we just close the handle. We call map view file. Okay, so here we're mapping it into memory, which is interesting. So we have our mapping, and then with CPX1, I'm guessing that's going to be the status. Oh, and just another cool trick, I guess. So with like Brave, Chrome, whatever, you can always like create, I don't know what they call it, but it's like search patterns, essentially, where, you know, if you do like this, it's going to like search in Brave because I'm using Brave, but if you do like question mark in Chrome, it's going to be searching through Google. But you can add some, so like if I give it like the MSDN prefix, and then I just like paste my thing, then it's going to use like a user-defined URL where you just put like a %s right here for the actual string that's going to be passed to it. So this kind of makes it easier to search rather than having to go like through Google, and then from Google you end up like on MSDN and blah blah blah. So there's that. So if we look at map view of file, which is right here, and we wanted to know what the return value would be. So if the function succeeds, the return value is the starting address of the map view. Okay, interesting. So if the starting address is equal to 0, we just shut everything down. If not, we start messing a bit through our binary. This part was kind of confusing to me, because I would expect the address to essentially be a DOS header, right? Like image underscore DOS underscore header. And this would kind of make sense seeing the 3C there. So if we were to just like DOS header as a pointer, we see that, you know, we're essentially creating a reference to e_new, which is an image empty header. But then we get something weird that's happening there. So it's going to look if the magic value is equal to 0x10b or 0x20b. If it does, it like skips back to the close handle. But I'm not sure. I'd have to dig into this, but I'm not sure exactly why it's looking for a different like magic number there. Because typically you'd expect what is it, like MZ something something. I'd expect like 4D for A to essentially be what it's looking for, right? So I'm not sure exactly like why it's looking for these specific bytes. I guess we can try to look at them. Okay, so anyways, no clue what's going on there. But we do know that this is going to be like an NT header. And from there it's going to create references to a pointer to its first data directory entry. Okay, so if it starts with 10b, then we skip directly to this third entry of its data directory. Hey man. And if not, we just reference the first data directory. So I'm not sure exactly. I guess we can put a pin on this one. How do I apply tags again? All right. So from there we see that it's going to get the first data directory, well, the virtual address of the hey folks. So it's going to pass the virtual address of the first entry into the data directory and the anti-headers pointer. So I guess we could retype this. Let me just make sure I'm not saying anything stupid. So this would be what is like image export. I just use the image export directory because the structure is a bit cleaner usually. Does that feel right? Characteristics. That does not feel right. Let's revert that change. Okay, so let's just keep moving on with this one. So we know we have an exported structure there, and we have our anti-headers. So let's just switch that one. Is it going to be a DOS header and anti-header? EBX1, which is our image DOS header, which makes sense. And then we have this one, which we said would be where is it going to be used? And don't, shy away from correcting me, guys, if I'm saying anything stupid. I'm learning as much as you guys, so. So if we look at arg1. Oh, interesting. So it's using arg1 against edx2 number of functions. Okay, yeah, so that won't be an export directory. What is that going to be? P64 optional header. Oh, interesting. Let's just go check that structure in the meantime. Let's do Virgilius. Whatever. So not there. Oh, interesting. Okay, so P magic is equal to 20p. That's good to know. Where was I? Right here. So we have our data directory. We have our virtual address. And how is argwin being used? Because we're comparing it to a number of functions, right? So it should be like a D word. Because we see that if the number of function is smaller than the expected number of functions from is that our okay, from our export directory, yeah. And what's the underlying type of a data directory? Virtual address. Yeah, okay, yeah, so I'm wrong here. That's not good. Because that would be equal to a single data directory. Kind of curious to see. So I know it's a virtual address. And we have, okay, I have the table itself. Okay, so this one would be like an image data. No, because we're getting like the first and second entry. Anyways, I move on from this one for just now. So we do have, you know, some form of resolution right there, which it looks like, you know, function resolution, where we see it's accessing its name. What else? It's accessing other fields, namely one at 0x10. If we look at this one, export directory, 0x10 would be its base. So this one would most likely be something like an image export directory. It's getting its base. Is that it? SI1. Oh, that's kind of fucking with me. Anyway, so just to keep things going for the quote-unquote intro, we do see like a bit further on that they are getting the proc address of a process name, which is returned by whatever like this returns, and our and the header. That's so fucking weird. If we look at get proc address, it should be like a string as the second argument, right? Get proc address. Yeah, okay. So it's an MPC string as the process name. Okay, so I guess like this combo somehow returns a process name, I guess. What else? So we are in get proc address returns. The value is the address of the exported function or variable. So this is going to be a far proc from there. Can I type it as a far proc? From there, what else? We store the pointer into this one. For the function, we're looking at E9. If it's equal to E9, it's going to do nothing. Okay, if it's not equal to E9, it's going to enter. So I guess it's expecting E9 as the first byte of that function. So I guess we could look at like kernel 32 just to kind of just give me 2 seconds. Let's try to get where is kernel 32? Let's get the copy of this bad boy. Did I just get the name? Malware, pedia, and let's just paste that here. Then let's open this bad boy. So we look at like the first byte of and let's open it the assembly. Let's do like what do we see? We see for 8FF. So whoops. Why would it be looking at 0xC9? What's 0xC9? Okay, nothing. So let's keep on moving. We see, yeah, so we like clearly have, you know, some form of like process resolution there. Well, some API resolution there. We have some calls to virtual protect. Okay, so E9 is the jump code. Interesting. So if it's not equal to E9, meaning they are, I'm guessing they're trying to identify if there's a hook, but I'm like, why would it be breaking? So is this like whole routine just to identify if the API has been hooked, and if not, like it tries to essentially do what I'm assuming is potentially like an indirect syscall? I feel like this could kind of make sense. Okay, and I guess like if it's identified that it's not hooked, it would just like break and kind of move on. Alright, so let's make some like bold assumptions that will probably end up being wrong. What else? Okay, so that is most likely it. So this would kind of check out, I guess, based on the not ton of experience that I have. So let's walk back out of this function. Let's go back into our load APIs function, and we see it does this for like a bunch of DLLs. So this being said, and I guess to make this a bit more exciting, we can load this into like triage just to get an idea of exactly what's going on. Let's open this triage. I should have done this earlier actually. So let's not give it any arguments for now, since we haven't looked at like which arguments it accepts. Let's just run it bare bone and see what happens. I obviously already like know what's gonna happen, but just to give you guys an idea of what's going to happen. So let's just extend the analysis a bit, and you can keep like a close eye on all of the files that are there, and just like that, poof, they are all encrypted. Let's try to see what's in one of these, and we see that it's all just oh, that closed itself. But yeah, we see like blah blah blah, like a bunch of random strings, and then .devman. So we can assume that this is potentially the name of this ransomware, and we can also identify that it's ransomware based on the sheer fact that you know, it's just encrypting everything. I guess we could validate like a bit more. We see not all files have been like modified. If we go and look into our program files, so we see that just like the raw files have been encrypted. The folders haven't been modified yet. Do we see some change there? Not quite. Do we have more stuff on our desktop that we should look for? No. Do we have anything into our public users? We see another file that got encrypted there. We do see there's a log.log file. So I will like extend this a bit. Let's give it like 10 more minutes, and let's get back in the code in the meantime. So if we go back into our main, so we have some, you know, API stuff going on. I still guess I still have to put a bit more time into that. Another interesting function was this one, where we see just some characters. Let's see if there's where's the display as? No display as for this one. We see like some interesting strings like expand 32 byte k. We see some strings there. We see this value being repeated. Okay, it's not exactly the same. It's like incremented by what 0x100 there. No, 0x 100, yeah. And then 0x, what, like, where is it for? 8, 9, 10, well, A, B, C, A, just by 2, 0x20. We see, and I'll go over this a bit later, where we see some global variables being initialized. What else? I think this function broke down a bit in binge. So we see more functions being called, and if we look at the string that we had just above, because Google is our friend, so we see it is related to you know, encryption stuff. It's apparently a magic string, potentially related to like salsa 20 or cha-cha 20. What else? Again, I guess check wiki. The constant word spell in ASCII. Okay, as the initial state? Okay, oh interesting. So the initial state is expand 32 byte k. That's good to know. So we know that like this is most likely encryption related. What else do we see that kind of jumps at us? We see more operations there. Nothing too interesting there, just ups. This one gets called a bunch of times. We have this one, we're passing a global as the first argument, and whatever this function is. So we're seeing some multi-byte wide char being called with and what's being returned? Argban. Okay, so there we go. So it's probably just like a conversion from a multi-byte string to a wide char string. I'm not sure exactly what's going on with all of the code around it, but what else? So we see the globals, we see this function being called a bunch of times. We did see that string, which I was able to revert back to. It's some weird string rrr.extend. Maybe I'm missing like a few bytes there. So at this point we know that this is like encryption related. What else can we infer? We see that we're looking for like 0x dead and then 0x beef in this one, where 0x80 is so that's 70. Is it close by? 70 and 78. That's 58. Okay, so it is like quite far. So we're seeing like, you know, two words being referenced there, so dead and beef, which is somewhat common. So I'm guessing this could be a flag for something, and then this flag gets stored into this global, so we could just like rename it something dead beef. And then we just return. So what else? We get our command line arguments, and this one is going to be interesting. So if we look into this one, I think this would be a good time to kind of just show the decryption routine, I guess. So I did end up, like, thanks to ChatGPT in part, coming up with this function. Let me just try to make it a bit cleaner. Do I still have this one open? Right here. So essentially just yeah, AI always saves the, well, it saves the day. So, yeah, sometimes, I guess. Not if you write an entire RE tool with AI that ends up just being slow. But yeah, so we can take like our current, so it's going to iterate like every over every byte. So we're just going to start by doing a what's in it in English, subtraction with like a given value, like we see in the codes. In this case, we're seeing like 0x2b minus our current value. So we could just paste that in there. So it's 0.2b. So 2b minus, and then we have to get our multiplier, which is going to be 0x24. Right there, and then we can take our string for this one, which is just going to be this. Let's take it as row x, and maybe I should put those side by side instead. Let's give us a bit more room. So we take this, and then we can just run this. We see it gets decoded as back p. thread.rip go then. What's thread.rip? Oh, nice. Oh, is it? Okay, yeah, so it's the Nike stuff. Oh, nice. So registration are open on this one. Oh, sick. Thanks, Toast. So we can see like that this argument is going to be -p, and if we kind of repeat that all over and over, so we see like in this case the value to subtract from has changed to 0x18, and then we're multiplying by 0x2d instead. So I kind of just like went through it and decoded all of these manually because I'm not smart enough yet to make a binge script that adapts to every use case and everything, but I try to do that for my blog post. So the arguments that we do see as being, parsed by the ransomware are tag P. A bit lower we have tag M. We have dash logs. We have dash size. No mutex, which fits with what we were seeing earlier, where it's like spinning up a mutex. What else? We have like quite a few string comparisons here. So we have the value local, net. We have backups. And what I ended up with, we see that the global will be assigned a different value for each. So let's just look at this one. We see that it's going to be like either 0xd, 0xc, 0xb, or 0xa. A bit like right here. Okay, so I could add this one, I guess. So we have 0xe that is going to be used if no values has been passed. So let's just add to this enum. What was it? This one. And let's call it just like default. 0xc, and it automatically did the thing. And if we look at like the code itself, we're going to see that so it's always comparing like the value that was passed in the argument, the value that was passed in the arguments. So it's looking if it's going to be all. If it's not all, it's going to check if it's local. If it's not local, it's going to check if it's net. If it's not net, it's going to check if it's backups, and so on and so forth. So we end up knowing that like this global is what one could consider, I guess, the encryption mode. Like if it's going to potentially do network, like encryption against network assets, or if it's just going to run locally or only against backups, and blah blah blah. So this was like fairly interesting. Let's just see if our triage run is over. Okay, cool. So it ends in a few seconds. We can terminate it early, I guess. Cool. So we see that it drops a readme.txt. Good afternoon. As you can see, I've been attacked by a ransomware program, which is a nice intro, I guess. We, the Dragonfrost Ransomware Cartel, offer you to make a deal with us. We can make a deal with you. All you need to do is contact us by the following instructions below. We are in no way connected to politics. We always keep our word. You have a chance to decrypt your files and avoid being published on our blog. Use this opportunity, and also don't waste your time. So from there, they go over the communication process. So they say that they have provided us with a special link. Then they allow us to make a test decrypt and get the full list of files stolen from us. And then they're going to negotiate a price, which is like standard operation, I guess, for ransomware groups. They also give us their website, a unique ID, which I won't be sharing, a TOX identifier, some recommendations. Do not try to recover your file with third-party programs. You will only do harm. Do not turn off reboot computer. Be courteous in our meeting room, which is a nice addition. I found this interesting. Do not procrastinate, which is also a funny one to see, and then references to their blogs. From there, what else do we see? We see that it's okay. It's just doing some like miter mapping. So we see that it is dropping some files into C user app data roaming Microsoft Word startup readme, which is an interesting like choice of path, I guess. It reads the user profile data for browsers somehow. It modifies a bunch of files. And it accesses, so it changes the wallpaper, or at least like it tries to change the wallpaper to wallpaper white.png, which is interesting. We see that it starts by running and then it runs WMIC shadow copy, where I guess that's shadow copy ID for something, and then it goes on to delete it. So it's going to delete shadow copies, which is expected, I guess, from a ransomware, because they don't want you to be able to just like revert back from those shadow copies. And this is just, I guess, the activity of me playing with the machine. What else? We see there's some network connections, so it's going to use what I'm assuming was like a local IP, and it's trying to connect to 445, which is it Samba? Yeah, okay, so it's SMB. So we see it's trying to like potentially encrypt remote drive files. And it does so for every IP on what's that, like a /24. So from 10.127.0 / 0.0 to 255. Oh, it also does so for interesting. So it skips to, okay, it also does so on 255 dot whatever. Okay, and what else we have? Our replay monitor, and we have dropped a readme and a file.devman. So the readme is going to be our ransom note. So that's interesting. And then what I ended up doing is also running it with a few arguments. I think it's this one, right, where I ran it with /log. I wasn't sure if it took an argument or not, so I ran it with one just in case, but it ended up like not respecting that. I played a bit with the size, and then oh, I did a typo in no mutex, so I guess it most likely still spawned a mutex. And then I told it to only encrypt stuff in the C program files. We'd go over the p argument after. So we see that it dropped c/user/public log.log. And if we take a look at this file, let's go put it in there. Let me know if I'm going like a bit too fast or whatever. I'm just trying to get you guys to see what I ended up finding. Not Dragon Force, let's put it there. Let's open. Oh. Come on, buddy. Where? DEVMAN. DEVMAN. And let's do, which one is it? Select log.python. If we look at our log file, we see that it's gibberish, so it's most likely encrypted. Alright, so at this point we know, a bit more about what it's doing. It's modifying also some registry classes. It tries to change the wallpaper style. We see that it's referencing, as we mentioned earlier, more stuff, more wallpaper stuff. They're super heavy on the wallpaper stuff, I guess. And they did open the language reg key, which is interesting. What else? It's enumerating processes. Okay, so at this point we can hop back into our sample. So we know we can like trigger different encryption modes in terms of what it actually encrypts. What else did we end up finding through these strings? We see that it's creating a file right there, which is most likely our log file, right? So if we walk this back, LP file name, which is a interesting. Do we have another reference somewhere right there? So it's being referenced. Okay. So one could assume like it's potentially related to logs, I guess, because it's copying a string. It's comparing it. What else does it do? It fetches like something at an offset. Anyways, I won't delve too much on this. So we know that this function is parsing arguments, so that's interesting. What else can we get? This one right there. So we have more functions referencing some globals. Not too interesting. So it's preparing some file creation related things. What's our file name here? And so we see this global gets potentially assigned in the like encryption stuff. What else? So it is creating a file with what security attributes. Open always, file flag write through. I'm not too sure about file flag write through, so we can look that up. Write operations will not go through any intermediary cache. They will go directly to disk. Okay, interesting. They're just making it write directly on disk. What else? Open always, I guess we could look at. Opens a file always. If the specified file exists, the function succeeds, and the last error code set is already exist. Okay. If the specified file does not exist and is a valid path to a writable location. Okay, so it just opened the file regardless of it if it exists or not. What else? Is the token handle used there? So file share read. We can look that one up. This file share enables subsequent open operations on a file or device to request read access. Okay, so it's allowing multiple processes to request read access, even if there's like a lock on it, I guess. If this flag is not specified, but the file or device has been open for read access, the function fails. Okay. Interesting. Desired access, we could look at what is 4,000, or what is the, like for 1,000,000, I guess. Is it, so we have, okay. File flag overlap. The file or device is being opened or created for asynchronous I/O. When subsequent I/O operations are completed on this channel, they have been specified in the overlap structure and be set to a signal state. Fine. Okay, so they're just allowing for async file writes. So that's fine. How's everyone doing so far? Everyone hanging in there, despite my rambling? Alright, so we can keep moving on. This one was interesting. So when we look at it, we see that it's going to write what is like presumably configuration information. So we have this string here which says like plus configuration. We have this one which will contain what is referred to as gbuild key. And from there we can like infer a few things. We had this one which is an instance key. We have a custom icon thingy. What else? We have a reference to a custom extension, a time sync, the encryption mode, which is interesting. And it does like refer, it does go and like read the global that we had identified as the encryption mode. What else? We have the full encrypt threshold. So that's interesting because I guess you can potentially just like partially encrypt files, like just enough to kind of mess with the victim, I guess. The header encrypt threshold, I guess it's something similar. Header encrypt size. Okay, so I'm guessing each encrypted file has a header. Auto encrypt chunk percent, encrypt file name. Okay, so I'm guessing this is going to be... Oh, interesting. Okay, sorry. And then we have a bit more stuff there where we have a job title. If the global scheduled job is not equal to 0, so if it's enabled. We also have a job description. We have a job start, presumably a time, which is interesting. What else? We have kill right here. What more do we have there? We have use sys. This one is interesting. I ended up finding another article that wasn't on Melpedia that like more accurately represents what we're seeing, so we'll look at it after. We have whitelist, which is interesting. So they potentially like have a whitelist of files not to encrypt, presumably. What else? And then a nice end configuration. So this like is most likely just a function that dumps the entire configuration of the ransomware. So there was that. If we, and I guess we can also take a look at the logging function. So it was interesting. Let me just get back to it. So this was just a wrapper, and if we look at this one, we see that it's always going to like print it on a standardized format, which is like 3 decimals and then a hex value. TH, potentially signifying thread. So what else do we have there? We see a call to sprintf. We fetch the current thread. We have another function being called that is passing in an empty pointer, hours, minutes, seconds, and then the current thread ID, which matches with the th that we saw earlier. And if we look at this one, it's just printing all of this. So we said that the first argument is just an empty structure, and we're calling vs or printf on it as the third argument. And then our second argument happens to be var7, which is the format that we had decrypted right here. So that's going to be the like string template. And then argc, which is presumably just like the variadic arguments. I wonder if I could... It doesn't change anything. Okay. So moving on, what else do we have? Is this being called elsewhere? No. So we see that it is like writing to a file, which, you know, I assumed was a log file handle, so a handle to the file in which it's going to like drop logs of what it's doing. And it only does so if... I feel like this is wrong because we're writing twice despite this. So I'm guessing maybe it accepts like a custom log path, or else it just has a default log path. I guess we can walk through this one a bit. But anyways, so we are writing to a file, and then we just handle some structures. So we have our logger function there. If we go back, we have yeah, our gbuild. Okay, so we have our config dump there. What else do we have? Let's go back. Here we just get the current like process owner. So I'm guessing they're just looking to know which user they're currently running as. If we decode this first string, so it's running open process, as we can see right there, with process query information. So we get our process handle. If it fails, we log an error. What else? We do open process token with a token query. I guess this we could reformat to be a bit cleaner. Let's see how it's being used. Okay, so it's just passing it there. And if it does so, it prints open process token failed. What was with this one? Get token information. Okay, so we're fetching token information. So it's fetching the token user. So we could look at like the token information class. Token information class. So we have what is token user, and it will return a token underscore user structure, and guessing it's going to return it into token information there. Is that it? It's going to be returning it into our handle. Let's go back. Our out is our token information right there. So we can retype this one as a token user. It's going to be a pointer. We don't get more information about it. So I'm guessing this will return like... Okay, yeah. Token user, which contains a SID and attributes of a given user. Which makes sense. So we are fetching the SID, and then we are doing a lookup against that SID, from which we will get back a username and a reference domain name. So it's being started here. It's doing something with the slash. So we know they're just like fetching the username. What else? Lookup accounts it failed if it fails. If not, it keeps going on. Okay, I'm guessing this is just a fallback mechanism where if it didn't work, it's going to... okay, no. Yeah, so if the get token information failed, then it's going to print that. If not, it's going to get potentially like the username. Let's switch up the music a bit. You guys have any recommendations on what we could listen to? What is Spotify giving to us today? Just to Mastodon, I guess. Alright, so we are getting a, let's call this one like username. And then we, okay, so that, you know, that checks out. So running under, I guess like the current username. What else? So we get more token information. We get our handle to our... Okay, so what's it doing there? Okay, yeah. So we are fetching the token elevation information class. So it's going to return a token elevation structure. Where's this one defined? Token elevation, if we take a look at it. Token is elevated as a keyword, so it's checking if the process is currently elevated or not, which is good information, I guess. It does some stuff related to time sync, so it starts by printing out running time sync, and it imports w32time.dll, which I wasn't super familiar with, so let's take a look at that real quick. w32time.dll. Let's open this one. What the fuck is that? Windows provides the facility for third parties to build custom time providers. Okay. Time providers are interesting in that they can be used as a Windows auto. Oh, interesting. Huh. Ever seen the Family Guy episode where the bald guys lick each other's head? No, that doesn't ring a bell, but I'm not sure I'm going to try that anytime soon. Yeah, you could always try to reach out to your core and see if he's down to do it with someone else, but I know I'm not. Microsoft lightly documents the time providers, so we can look at it there. The important points are that the time providers are implemented as DLLs that match the architecture of Windows. Hold up, let's try and look at this. Oh man. No, I do not fuck with that. So let's go back. So the time provider are an interesting auto-run mechanism for 3 reasons. Time providers are not well known documented. This is fair. The implementation of time providers allow for installing any number of time providers. So a custom time provider can be installed easily. Time providers can be enabled or disabled, which interesting with the single registry value. From an auto-run perspective, there is no escalation in privilege here. One must be an admin to set up a time provider. Okay, so that's interesting. So does it only try to do that if it's running as an elevated user? Nice. Okay. And the timer provider configure the Windows registry must be a reference on a non-disk file. Interesting. And then you must create a registry arbitrary name, game time. Okay, interesting. Let's look at how it's being used. So we have our deal on main. We have our time provider open, time provider command, register. So it's registering a key. It's setting your reg key value. Okay, interesting. But it's only doing it through registry keys, which we haven't seen being open. So I haven't like decrypted the config or whatever, but I'm guessing maybe timesync isn't being used in this sample. And let's look at the doc. It's both for variety of hardware devices, network time protocols. Time providers are managed by the time provider manager. Okay. Time provider open, registering a time provider. Okay, so it's typically purely done through registry keys. What else? Sample time provider. Okay, so they're just giving us an example which looks a lot like what we saw in this. What else? Time provider. Okay, so we have for running timesync, and then just below we had our W32 timesync now. So it was a DM that the bald is blinding, and funnily enough, it's not the first time I've been told that. Was it who is it? I think it was Baki that actually made a meme about that. I should try and find it again. If anyone listening to this has the picture close by, just DM it to me on Discord, and I can show you guys. Okay, so we do a get proc address on W32 timesync now. So I guess what we could try to do is seeing if I have that on my system right there. Let's once again just paste that there, and let's open it in Binja. Let's let it do its thing. In the meantime, we said that it was W32 time.now. Yeah, there we go. Interesting. So it's not doing it done. I guess it's registering. What is it doing? Yeah, so it's making like an RPC call to the W32 named pipe, and it's got an alt. What else is there? Okay, so I guess I'll take a better look at this for the blog. But we do see something interesting. So the first argument is going to be network address. What else? What's the second argument going to be used as? Okay. And the third one, okay. Okay. Let's dig a bit into Google and see what comes up. like... Oh. Oh, nice. And do they provide more information? No. Okay, so if it should be blocking and more flags, I guess. That doesn't feel right. Mm-hmm. Okay, so is it just like trying to sync to a remote server? It's a bit weird if it's just that. Not sure what the like benefit from doing that would be. Anyway, so we get our proc address and then we call it with 0, 1, and 3. That's even more confusing. So we're trying to sync it with nothing. And then we... yeah, keeping it await and more flags. That's weird. I will try not to overthink this one too much, so we're, I guess, just syncing time for some reason. We are getting our current path, current executable path. We're logging that. We are checking if it's a WoW64 process. What else? We have a long string copying executable. Okay, so it's going to copy itself somewhere, I'm assuming. Yeah, okay, so we're just copying ourselves somewhere. I'm starting to feel like this is just like a string table resolution thingy where like there's a bunch of strings stored like maybe in an encrypted config or whatever, and it's just accessing it at like this, you know, pseudo address and returning it into this buffer right here. So maybe at some point I should try and look at this one a bit deeper to figure out how we can reference stuff in the config. What else do we have? Oh, interesting. This one I hadn't seen. Ooh. Let's just put a pin on this one for now. So we have task scheduled. Okay, so we know that this part is most likely like just related to task scheduling. Do we have more strings? We have our get sysname. So this one was interesting because it's resolving two like kernel drive, well, two like .sys files names, like either truesite.sys or rent drv2.sys. So I'm guessing this, you know, either rename to something like get driver name or some shit. What else do we have? Start getting kill proc. So I'm guessing this is going to try to kill a given process. What's this one? Oh, interesting. Okay, so it could be worth resolving this one. So let's put that there. Let's put that there. Let's do our little dance. Raw hex. See, we also have proto12. And then it's going to be minus 12 times 0x14. Starting proc. Let's do it again for this one. And 0x12. As a surprise to no one. It's going to anti-query system info. Does it put it somewhere? Okay, let's just save it here for now, I guess. Let's get this one. Let me see, 37 times 24. Nice, yet another entity alert resolution. Alright, so we are getting the proc address of anti-query system information. So we could actually retype that global, so let's do anti-query system information, and let's retype that global as a pointer to that function. Let's remove this. Is it going to right now? And let's just call it G because it's a global. Use a pointer. Great. So we are calling. Oh, hold up. No, that's not right. Because we're passing it arguments. Okay, no, yeah, I'm right. So that's interesting, and then we go ahead and create a thread with these two functions. And what does create thread return? The function succeeds, the return value is a handle to the new thread. And it's being called twice, so I guess it's spinning up like two threads. So let's call it GH. I guess we can type it as a handle. Hold on, let's do it all in one go. Okay, so this is interesting because we have like two new functions that are being called through threads. Examine, oops, I'm late. Yeah. Shame on you, man. But yeah, yeah, we will see it a bit later when we find the the mutex name, but it is a Conti variant. So if we look at the two threads that are being created, we can look at it like real quick. So we have more strings that are obfuscated, so let's copy them real quick as raw X. This is super janky to do this manually. Should really figure out the script to do so, but for now it works. I haven't like familiarized myself to the binge script. I'm still doing like a bunch of stuff manually. This one, nope. Copy address, copy as. Then we have 04090909. And something that interesting, I guess, could be useful from a scripting perspective is that strings always end with 3 times the same character, and well, the same like value, and that value is always used either before or after our actual character while being subtracted. They use add obfuscator, I think. Can look it up real quick. I'll need to register changes. Interesting. I'll give it a look for sure. Cool. Well, thanks a bunch, man. Examine once again, feeding us valuable intel. All right, so we had this. Let's go back into our script. And the values that we have this time is -9. What the fuck is this song? And then we multiply by 1f. Starting priority process, okay. What else do we have? And then it sleeps for a bit. 15 milliseconds. Well, this is not equal to 0. Okay. Do a bit of stuff there. So we... Interesting. Okay, so we already see some references to antiquated system information. More logging info. Okay, hold up. So is it just I don't see, I'm guessing it could be one of these functions. At first glance, I don't see like a process being created. So we're gonna get this one. Okay, so it does seem to just like get some process information, and it either returns 0 or it returns the result, which is going to be a PID, but the PID of which process? Of itself? Let's take a look at the default behavior and to query system information. So we have the system information class that we want. We have, okay, so this is our out. So in this case, we're not saving it anywhere. And we're just preparing the return length. So I guess we could retype like these two to get a bit more information on what's going on there. So when we fetch its system process information, returns an array of system process information structure. So I guess we could just like system process. Does that not exist? Identical to except for the sequence number member, which is a unique value assigned. Okay. I guess we could use like system basic tune. Let's create the type, I guess. Doesn't quite make sense, does it? Oh, there we go. Okay, that makes more sense. There we go. Cool. All right, so we are getting the image name. And let's call that like image name. And then we get the image name length. And then we do something something. That makes sense, especially with Conti inspired malware. Yeah. So what else do we have? We have this thing that just, if I remember correctly, it's like creating a... It's just like creating a, yeah, like a Unicode string or something like that. Let's try that and see what comes out of it. There we go. Does that make any kind of sense? It seems to stick so far. Okay. So if we look at the unique process handle, so that's going to be a handle. Okay, so it's just going to print the handle, but of which process? Of itself? System class system. Wait, where did I? Dude. Okay. Pointer to buffer that receives the requested information. Varies. So we are initially dumping it into a nil pointer, only getting the return length, which is a bit odd. But let's go along with it and then yeah, okay. I'm not sure why they're doing that like twice, but okay, so we are okay. So just like getting its current bid. Let's call that like maybe get current bid. Alright, so let's get back to our initial function. So we have this, and then we have this. So it's going to try and terminate some processes, or a process. We have a bunch of strings in there. So we start with 62 B06. This thing. Event to be Ruby. To be so let's run this. We have once again an open process failed, which makes sense because we are and we know this is going to be our bid. Let's go forward. terminating PID. So this is interesting. And then we call terminate process. I'm assuming this is just going to say to whine about not being able to terminate the process. What else do we have? I'm guessing it's just saying that it successfully killed the process. So let's call this one get process. And arg1 is being used never. No clue. Alright, so if this is set, we go ahead and kill a PID. Something related to killing PIDs, because we like descriptive names, right? And then we sleep for 15 milliseconds, and guessing this is just like okay. Man, why would it just like open and kill a PID? Because the PID that it takes as an argument. Oh, interesting. Okay, so it's resolving a string and it's trying to kill the PID of that string. So I would have to like figure out the kind of string resolution from the config thingy. So like, let's call that kill some process that is apparently named. Examine says Dragonforce only had these additions previous to system. Bring your own vulnerable driver for terminating processes. And encrypted embedded config. I looked at it months ago. I don't remember all the additions. DEVMAN might be different. Interesting. You may have missed it early, but we do ended up finding references to like 2 drivers that were used for something. Alright, so let's go back from where we were at there. So we have, this is our first thread creation, so it's like going to kill something. And then we have this one, which also kills something. Okay. Well, let's do like this. Yeah. Easy. Alright, so let's call it just call it a wrap around that. And this was called in our main right here. Okay. Okay, so this is like part of our process killing operation. I'm not sure exactly, sorry, which process is being killed, but yeah. Alright, moving forward, we have a mutex name. Okay, so this brings us to the part that ended up having me finding a bit more information. So we are like printing out a mutex name, and then we create a mutex with a name, which is all fine and dandy. But if we Google for that string, we have a few references to this, right? And I did, let me try and find the group IB one that was interesting. Let's do group IB. Just give me the fucking article. There we go. So, oh no, this is the... Where was it? I had it. Oh, there we go. Okay, cool. So I don't recall exactly how I found it. I found it on Google, whatever. by just like pasting the string. But we do see that there are like a few mentions of this mutex. So Sang4 associated it to logbit green, interestingly enough, making reference that logbit green uses the new Conti-based encryptor, which was interesting. Then we also have some references to this is just from the AnyRun analysis. So this is a direct reference to DEVMAN, and then we have the group IB reference, which was very nice. Or do they not talk about the mutex? Oh, interesting. Or was it based on the hash? Yeah, I think I had it based on the... No, yeah, I'm wrong, sorry. This was a completely different sample. I think I was initially led to this one, so let's ignore this one. Just check if the arguments were similar. Oh yeah, okay. So what got me to this one was the arguments, which they also specify was inherited from Conti. So we remember seeing the /p/m/log/size and new mutex arguments. So this was an interesting find. And they says, in contrast to Conti, DragonForce embeds a configuration inside the binary so that no command line options are needed. However, when command lines options are used, it will override those specified in the configuration. So this was interesting to find, because they do state that it wasn't like in a .config section or whatever. They just state that, you know, these are the flags that are being used, and they're embedded directly in the file, meaning that, you know, we could probably reverse engineer the config from the information provided by them. And the stuff that they ended up finding was super similar to ours. So we remember, oh, there we go. So that's even better. Earlier we saw like the 0x-dead and 0x-beef, which apparently is the start marker and then the end marker. We saw mentions of our build key, the encrypt mode that we also had identified at 0x-A, B, C, and D as all local network or path. We saw the time syncing, the logging options and file path. What else? We saw something related to kitting, to the the drivers that we had mentioned earlier, so either none, true site, or rent drive. The driver offset and size. Okay, interesting. Driver encryption key. So they've got like a few things that we haven't found just yet. We do have a list of processes to kill, custom extension, and some whitelisted paths and extensions. And then, you know, custom ransomware name, the wallpaper option, size, and file path. So this is pretty interesting. I haven't looked at the drivers. TrueSight is actually a rogue killer anti-rootkit driver. Nice. Developed by Atlas Software. The company Atlas has already published a fix in v3.4. The 2E044 control code terminates the target process provided by its bid. Interesting. Rent driver developed by Hangzhou Shunwang Technology. Not much information about the driver can be found online. The control code terminates the process provided by its bid. So same thing. What else do we see? The hashes of drivers, the privilege escalation, we haven't seen that just yet. The encryption schema. Wallpaper icon, and then the ransom note, which is interesting because it's a different ransom note, right? Your files have been stolen from your network and encrypting with a strong algorithm, so it's not quite the same. There's references to logbit 3.0, I guess, for the config. Conclusion, blah blah blah. Okay, and what else do we find that could help us? Oh, interesting. So they do wipe EVTX logs. It's a Windows service. I wonder if there's references to like the time stuff. Persistence via scheduled task. The Dragonforce variant of Conti ransomware has the option to create scheduled tasks. It uses the COM task scheduler class to schedule tasks daily to run the current binary. Interesting. What would choose? Okay. Is that what we saw? Not too sure. Interesting. I don't seem to talk too much about the time sync stuff, though. That could be something we could dig into a bit further. So yeah, so this is kind of what allowed me to like connect the dots a bit more, I guess, about like its reliance on previous Conti samples and source code and things like that. So that was interesting. So we have that. What else do we have? We have actually, let's I think I'll take like a 5 minutes just to take a quick bio break, and I'll be back after that. So feel free to spam the chat or whatever in the meantime, and I'll be back in like 5 minutes at most. Alright, so let's just take a bit of time to catch up with the messages. Examine not inspired. It's pretty much the same thing with a few more additional features. Yeah. Yeah, it does feel like an iteration over like, you know, small improvements that they did, I guess. You should also look at Logbit 3.0 slash Logbit Black. The version leaked in 2022. It was pretty fun, but the threat actors still continue to spam it. Nice. Yeah, I can take a look at this at some point. I'm not like super familiar yet with how ransomwares work in general, so it still feels like you know, a bit of a beast when it comes to like more well-designed samples, I guess, if I can put it that way. Because like the main stuff I've been used to lately is just kind of shittier malware samples that are sometimes like, you know, AI coded, and they don't do a ton of crazy stuff. So I'm still, you know, getting into this slowly. In the meantime, yeah, I can let me paste in the chat. So for folks who don't know, I do have like a DFIR kind of centric Discord server. Let me paste an invite for anyone who's not in it. Do I find this? I feel like such a boomer when it comes to Discord. Let's do this. People. Alright, so this link will be valid for 7 days. Alright, so I guess we can get back into the sample slowly. So within our main function, we are now into so we call get native system info. I'm not super familiar with this API. Let's look at it. To retrieve accurate information for an application running on WoW 64, okay, retrieves information about the current system. Okay, so it's not super complicated, right? It just returns an LP system info struct, which consists of information about, okay, the actual system, like the number of processors and things like that. Interesting. Okay, so, and this is already typed correctly. The OEM, why would it fetch the OEM ID? That's interesting. I've noticed, so there's like these kind of math operations, I guess, scattered like throughout the sample. I'm not sure if this is meant to be like just kind of decoy to make like obfuscation a bit harder or something like that. But I found that it like usually doesn't do a ton. So we're like taking this value, you know, 62EB20. I guess we could try to Google that and see what it gives us. And it doesn't give us it done. Check if I can get them. Yeah, there's not a ton of references. Yeah, let's try. I don't know why I've been having issues with grep.app lately. It doesn't like always return something super useful. Yeah, so we don't get much more information. Like, this is what kind of annoys me, I guess. Like, you send GitHub, there's a lot more results, and then grep.app just gives me that. So yeah, so we don't have much information about what that is. But we see like all of these, you know, it's just like ending it with 0x8000-003. And then if, yeah, I feel like maybe, okay, yeah. So if the encrypt node is not all, we will double the number of processors. Is that it? It does not equal all, yeah. And if not, we just keep the regular number of processes. I feel like that should be backwards, right? Because you want more compute if you're going to encrypt everything. But whatever. Then what else? We store this value. We know this is going to be let's actually retype this as like a what is it? It's target file. Okay, so if it is either encrypting everything or just encrypting the local stuff, then we fall into this section. If not, we go into this section, which is either all or net. Okay, interesting. So I'm guessing like this is going to be the like local encryption routine, where we fetch our number of processors. We fetch. Why do I have that tagged as threads brown? Okay, I just roll with it. Okay, so we have our local encryption routine, most likely, or at least like, yeah, I should just call that like local routine, because we don't know if it's going to encrypt anything just yet. If the number of processors is greater than 0, then we create a new thread with this function as an entry point, where we are importing a public key, which is defined right here. And then this I remember looking a bit, where it's essentially just like searching for files and things like that. So search files and then the file that I'm guessing it's looking for. Search files done. So it's probably like creating a, oh yeah, and then we iterate over find next file. And it kind of breaks down here because of an issue I haven't fixed in the stack pointer values. But you know, one could assume that, you know, and this is like the essentially like crawling operation of the file system. And then we exit. So we're importing a key. Where do we save it? That's interesting because the handle isn't reused. The function attempts to find the CSP or the characteristic described. Okay, cryptographic service provider. Okay. Yeah, so it's just looking for a provider. Container of private key associated with a public key. In this case, since we're trying to ransom people, we don't provide a private key, so we're using this function. Okay. So it's just acquiring the context. What does it return? Okay, yeah. And the function succeeds. The value, okay, so it's just going to return like a boolean. Okay, which makes sense. So it's just trying to acquire a provider. So if does not equal 0, okay, and then it tries doing it through its local pub key. I feel like it's just preparing. No, but it's creating a different thread, right? Okay, well, I feel like this is like the encryption routine. Let's keep on going and just see what else we find. Yeah, for a bunch of garbage there. Okay, and then we restart with a new set of parameters. Okay, that's interesting because we saw what I had identified. Actually, thread params. This one is only used in local mode or all mode. Thread. Let's go to local mode. And then let's go and take this one. Thread. What else? Well, I think this could be like a file count or something. What else do we have? So after that, we proceeded creating a snapshot. We could retype this one, knowing that it's using the th32cs snap process flags. We know that it's sending it th snap process. Includes all processes in the system in the snapshot. To enumerate the processes, see process 32 first. Is fine and dandy, but we have structure reference. Okay, so just a handle, right? Interesting. And what was the second argument? To process ID, okay. Interesting. And it's giving it 0, so I'm guessing it's going to like reference itself. If we look at Process identifier of the process to be included in the snapshot. This parameter can be 0 to indicate current process. Okay. Okay, so there we go. So it's iterating over each. Let's go back and look at the example they give. Oh, interesting. Okay, so we do have a structure here, which is this. Is it defined? Okay, process entry 32. Okay. Oh, not that. That. We look at where's this? Okay, okay, so they're just setting up the size. This. Oh, interesting. Okay, so they're looking at all processes and they're looking at until they hit like explorer.exe essentially. Would that be it? Yeah, I feel like this is a bit broken, but I feel like the this is the output of that, and then okay, yeah, okay. So it's just like going through the list essentially and trying to find explorer.exe, and when it does, what happens when it does? Okay, so this could be the com stuff that was referenced in the, we have it close by, in this article, right? The com space, deleting shadow copies with com object. So let's give this one a bit of a better look, because we have our initialize X call, and then co-initialize security. Interesting, with impersonate. So it tries to create an instance with this, and what's the type of that already? It is a ref CLS ID. We have that type. Is it just like a CLS ID? Let me try and find again the yes, so let's try and look at it there. Let's see if we can recognize that UID. W, I don't feel like that's right. Do I have companion? Oh, yeah, easy. Okay, cool. Okay, so it is iWebM locator. And then we have some, okay, interesting. So let's just get back there. And we are fetching iWebM locator. The fuck is iWebM? WebM Windows. Oh, okay. So it's related to Windows Management Information. Okay. WMI stuff. So one could assume this is potentially related to where was it? This, where it's using WMI C. All right. So moving forward, we see. Do I have a type for that? IWM. Okay, so it would be in WBM. Just trying to find. No. Which DLL could be containing this? There was. I guess we can just look at IWBM locator. What does that look like? Oh, nice, okay. So we might have it here. Nope. Oh yes, nice. Okay, we have it. Cool. So we know that this is going to be a IWBM locator pointer, and yeah. They just screw up everything. Yeah. Okay, let's not do that. And where is it going to be used? Okay. Just trying to see if I couldn't try to like resolve which like method is being called. So if we look at it, does it get used? So here plus 0xc, which brings us to connect server. Okay, interesting. And that is going to like screw the living hell out of everything. So let's call it connect server. All right. And if we look at connect server, so this is going to be like this essentially. And then we have our network resource. We have no user, no password, no string locale, no security flags, no string authority, and then we have our IWBM context. And then our direct as a pointer to a IWBM services. Okay, so we have one connect server there. And then let's just call this one that as the type. Cool beans. What else? You have this string right here, which I haven't deobfuscated, so I guess this could be interesting. It's a bit all over the place, but we can always just let's do let's replace all of these. Let's make these all D words, all bytes. Let's replace all our 0x's with nothing. And let's remove new lines. Like this. Where did that put this little bugger? There. Alright, and we have -3 times 7f. Whoops. Is that right? Wait. Oh, what if? Oh, interesting. Okay. So it's parsing the string root simv2 and presumably this little dude. And what is root simv2? Namespace. Oops. It's a default namespace that contains classes for computers and hardware configuration. Okay. So it's calling connect on the... Wait. Nope. Dude. Okay, let's just ignore that for now. What else? What else? What else? We have set proxy blanket. Okay. So we have our proxy, we have our authentication service. We have 0, okay, and with no principal name, which is a bit odd. The auth level. The authentication level to be used for a list of possible values. See authentication level constant. Okay, so it's okay. So it's for the com. And then impersonation level with impersonate, which is fine. What else do we have here? So we have 1B, 60, 17, 60, 3E. We got this, and then we have 0x60. And times 3 WQL, whatever that means. 40, 5B, 0F, 5B, 67, 5B, 0F. And then we have from there 5B. Select over. Ah, nice. Okay, so this is where we're enumerating shadow copies. Interesting. And we are using pproxy, which was defined, I guess. Okay, through connect. Okay, interesting. So what does connect return? It returns an H result. And then pproxy is our, okay, is our struct to our IWBEM services. So let's ignore this part. This part makes sense. Yeah, so this should be a pointer. Should make things a bit clearer. Ah, nice. Okay, so we execute the query. And then what does exec query return? Where are you at? Exec query, okay. So it returns again an H result with the so this one is going to be a I enum WBM class object pointer. It should, oh, god damn it. Hate when it does that. Okay. Brr. Not the pointer. No, yeah, it should just be a pointer. Again, this one isn't a pointer. Dude, stop moving. Nah, fuck that. Okay, so we run this. And then it, yeah, I'm guessing it's just gonna like iterate over all the IDs that were returned. Let's switch up the music a bit. Alright, so we have 73, 20, 61, 20, 20, 20. And we have 20 there. And 23. ID, okay. Wow. Okay, so we have a good one here. This one's going to be a bit longer. Try to like somewhat speed run through it for you guys. And finally, this one. All right, so we have 0x51 and 17. Oh, okay, so I feel like I screwed the pooch at the very end, but we at least see, you know, that they're trying to delete shadow copies or something like that. Let's just take this one. Boom, so that's going to be our command. It's calling 164 disable, 164 FS redirection. Let's just take a look at what that is. Disables file system redirection for the calling thread. What is file system redirection? Huh. File system redirection in Windows is a feature that ensures 32-bit applications running on 64-bit version of Windows access the correct system files. I wonder why they would disable that. Okay, so maybe they just want control over which DLL will get loaded. Interesting. What else? Okay, so we temporarily disable it and then we run this function, which creates a process with no window. Oh, interesting. Okay, and I'm guessing this is going to be the process that's going to be executing the shadow copy deletion that we saw earlier. Let's call that maybe exec copy deletion. Interesting. Alright, so I think I will be calling this a day for now. Obviously, this warrants more research. Yeah, so I'll probably try and make a blog post for it, especially if I figure out a like binge script to resolve all of the obfuscated strings. You know, as always, you guys are welcome in the IRCC Discord channel. The link was posted a bit earlier. Otherwise, you can just like poke me on Discord if you want access and don't have access. And thanks a bunch for being there, guys. Thanks for joining, and thanks for all the tips that you all have provided during the stream. So see you guys soon.